share the use of calculus in life, and I'm going to do it in the following three parts. Respectively are the applications of derivatives to economics, virtual method and the moments and the center of mass. Okay, let's begin with the applications of derivatives to economics. In this part, I will focus on cost function, revenue function, and the profit function. Make a presentation. Let's see cost function. The cost function describes the total production cost of the enterprise on the different production Q levels, and the specific formula is TC of Q equals FC plus VC of Q, where FC is the fixed cost of production, does not change with the change of Q. VC of Q is a variable cost, closely related to the change of Q. If we differentiate the cost function TC of Q, we get the marginal cost MCQ, where MC of Q equals dMC of Q over dQ. The meaning of marginal cost is the rate at which the cost of production changes with the output. By understanding the rate at which the cost of production changes with the output, we can know how the cost of production changes under different output, so as to know the corresponding output at the lowest production cost, reflecting the economic cost of increasing production. A simple sentence. If the startup capital of the enterprise is insufficient, the output becomes extremely important and cannot be produced without limit. Sonadra went bankrupt because it produced without limit, without constraining the production cost. How exactly do I apply it in the revenue function? A revenue function is a mathematical model used in economics and business to represent how a company's revenue changes in response to changes in certain factors. Its basic form is R of Q equals P of Q multiply Q, or more than. R of Q is the total revenue function. Q is the quantity of goods or services sold. P of Q is the price of a good or service, usually associated with the quantity Q sold. The revenue function helps firms determine the most profitable level of production and sales, taking into account the price elasticity and the cost structure. Businesses can use the revenue function to forecast revenue, develop pricing strategies, and optimize production decisions. Now, I will tell you how to use it. Suppose that revenue function is R of Q equals 100Q negative Q squared. First of all, take the derivative of this function. Next, find the zero of the derivative function. And then we take a second derivative to see if the zero of the derivative corresponds to a maximum or a minimum. Finally, we can come to a conclusion about when and how much we earn the most. And then we see profit function. The profit function is a mathematical model used to describe the profit of an enterprise, which represents the relationship between revenue and cost. In general, the profit function represents the difference between total revenue and total cost. Pi of Q equals R of Q negative C of Q. Among them, pi represents the profit function, RQ represents the income function, CQ represents the cost function. Q represents the quantity. The derivative of the profit function provides information on how many sales to the profit reaches its maximum, and through this information, the business can make plans to obtain the maximum profit. A simple sentence. In the early days, Tesla had low output and high fixed cost, and would eventually lose money after calculation. After increasing output, Tesla began to make profits, but too much output led to high marginal costs and the loss of the company. So, in the financial field, no matter the cost function, income function, or profit function, are closely related to the derivative, which provides them with the ability to predict the cost, income, and the profit, so that enterprises can make better strategy deployment. Okay, let's see visual method. Visual method is an integral method used to calculate the value of a rotating body when a region rotates around a center axis and forms a rotating body with a hole in the middle. Let's see the formula. When rotated around the x-axis, V equals to pi integral from a to b rx squared negative rx squared dx. When rotated around the y-axis, V equals pi integral from a to b ry squared negative ry squared dy. The general method is difficult to calculate the value of this three-dimensional, but we can simplify this three-dimensional pattern into a three-dimensional pattern composed of one face. The picture explains the relationship between the different faces. The value of this third figure can be obtained by using visual method. A real sentence. For the design of glass bottles, Coca-Cola Company uses visual method to save glass materials so as to increase profits. The most prominent part is the smooth transition from the bottom of the bottle link. The outer radius for this part is r of x equals 5 plus 0.4x negative 0.02x squared, and the inner radius is r of x equals 4.5 plus 0.3x negative 0.015x squared. So we can draw the following one, which is using the visual method. Let's calculate. First step, substitution formula. Second step, expanded square term. Third step, calculated the difference. Fourth step, integral calculation. First, second, third, fourth. Fifth step, sum total. So we get a value of about 434.75 cubic centimeter. Finally, let's see moments and the center of mass. Moments is a quantity used to describe the rotational effect of a force on a point or axis. The moment is the product of the force and the distance between the point of application of the force and the point or axis of rotation. The formula of torque is M equals F multiplied D, Among them, F is the force, D is the vertical distance from the point of force application to the axis of rotation. The center of mass is the average location of the mass distribution of an object or system of objects. When analyzing the linear motion of an object, the center of mass can be seen as the center of mass of the object, where all the mass is concentrated. Let's see the formula. Now, suppose we have three moons with their masses and positions as shown in the figure. Then we can calculate their center of mass according to the formula we just gave. And the result is shown in the figure. And their moments as shown there. Bringing in real data, we can see moments and the center of mass. Thus, the center of mass of the system is located at 2.09, 3.27, 2.09. To sum up, calculus is widely used in the applications of derivatives to economies, virtual machine, and moments and center. And life cannot be separated from calculus. Thank you for listening.